Good day, grade 10 students. It's a brand new day, filled with fun learning experiences. I am your teacher, Micah, and welcome to the world of grade 10 science. Join me as we discover and experience fun and challenging adventures in learning science. To start with, I would like to request you to pause for a while for our opening prayer. Our loving and generous God, we praise and thank you for the bountiful blessings you have given us. Thank you for giving us a mind that can know and a heart that can love. Thank you for giving us the chance to continue learning amidst the pandemic that had caused a lot of changes in our lives. We are sorry for the times we have failed you. We humbly ask for your forgiveness. Father, help us stay focused on our studies. When learning becomes difficult, grant us the gifts of courage and enthusiasm. Grant us the grace to use our knowledge in making a difference into the lives of the people around us. All this we pray in your mighty name. Amen. Now, for today's lesson, here are learning competency and objective. Learning competency. Compare the relative wavelengths of different forms of EM waves. And here are the learning objectives. Trace the development of the electromagnetic theory. Evaluate how electromagnetic waves are produced and propagated. Lastly, characterize the electromagnetic waves. So what are you waiting for? Get your pen and paper and self-learning module. Let's begin this exciting journey in learning science. Are you ready? Let's go! Before we start, let me ask you some questions. Did you send text messages to somebody using your smartphone? Did you listen to your favorite radio station? Or did you turn your television on using a remote control? Did you know that all these human activities, like texting someone using your smartphone, tuning to your favorite radio station, and turning your TV on using a remote control, have one all in common? They all use electromagnetic waves or EM waves. And this will be our lesson for today, the introduction to electromagnetic waves. You have learned from your previous lessons in science that a wave is a temporary disturbance that transfers energy from one place to another. You have also learned the different parts of a wave. These are the crest, the trough, the amplitude, and the wavelength. You have also learned that according to presence or absence of a medium, waves can be categorized into two: the mechanical wave and the electromagnetic wave. What is a mechanical wave? Correct! When a wave requires a medium in order to propagate, it is called mechanical wave. But when a wave doesn't require a medium in order to propagate, it is called electromagnetic wave. Now, let's move on to your pretest. Please prepare your pen and paper for your answers. You will be answering 5 items and choose the best answer from the options. Are you ready? 1. What do you call the continuum of electromagnetic waves according to frequency and wavelength? A. Electromagnetic spectrum. B. Electromagnetic order. C. Electromagnetic line. 2. What do you call the distance between two identical and adjacent crests or troughs of waves? A. Wavelength. B. Frequency. C. Amplitude. 3. Which has the longest wavelength in electromagnetic spectrum? A. Microwave. B. Radio wave. C. Gamma ray. 4. It is a type of wave that travel with or without the medium. A. Mechanical wave. B. Sound waves. C. Electromagnetic wave. Number 5. It is the number of times a point on a wave passes a fixed reference point in 1 second. A. Wavelength. B. Frequency. C. Amplitude. Good job, students! And now, know your scores. Here are the correct answers. Now, let's move on to the introduction to electromagnetic waves. What is electromagnetic wave? Electromagnetic waves, or EM waves, are waves that are created as a result of vibrations between an electric field and a magnetic field. Electromagnetic waves are produced by a charge that changes its direction or speed. Electrons are charged particles that can produce electric and magnetic fields. But in order to create the vibrating electric and magnetic fields that are the characteristics of an electromagnetic wave, electrons must move. A changing magnetic field produces an electric field, and in the same manner, a changing electric field produces a magnetic field. There are also different properties of EM waves. EM waves are the all-transverse wave that propagates outward from a source perpendicular to the direction of the wave's travel. The creation of all EM waves begin with an oscillating charged particle, which creates an oscillating electric field and magnetic field. Another property of EM waves is that EM waves can travel in free space at the speed of 3 × 10⁸ meters per second. It is also one of the different properties of EM waves is that they possess different velocity of propagation in a different medium. When traveling between media, the wavelength changes, and therefore, the speed of EM waves also changes. Also, this change is different for different frequencies. At this juncture, I will be discussing the development of electromagnetic wave theory. The following are the scientists who gave contributions to the development of EM wave theory. Hans Christian Ørsted, a Danish physicist and chemist who discovered that the electric current in a wire can deflect a magnetized compass needle, a phenomenon the importance of which was rapidly recognized and which inspired the development of electromagnetic theory. Next we have Michael Faraday. He is probably best known for his discovery of electromagnetic induction. According to him, the changing magnetic field and electric fields are perpendicular to each other and to their direction of propagation. Therefore, they are seen as transverse waves. Next, we have Mr. James Clerk Maxwell. He is an English scientist who developed a scientific theory to better explain electromagnetic waves. He described how electric charges and electric currents act as the sources of electric and magnetic fields that form the basis of the electrical field of science and technology. Heinrich Hertz, a German physicist who applied Maxwell's theories to the production and reception of radio waves. He was able to perform many experiments that help explain reflection, refraction, polarization, interference, and velocity of electric waves. The Hertz, the SI unit of frequency, is named after him. Next we have Sir Andre Marie Ampere. He made the revolutionary discovery that a wire carrying electric current can attract or repel another wire next to it that's also carrying electric current. Wilhelm Gilbert. He discovered that Earth was magnetic and theorized that electricity and magnetism are not the same. The Gilbert, a unit of magnetic potential, was named after him. Next, Sir Charles Augustin de Coulomb. He developed Coulomb's law, which defined the electrostatic force of attraction and repulsion. The Coulomb, the SI unit of charge, was named after him. Lastly, Sir Albert Einstein. He formulated the concept of photoelectric effect. He was a German-born theoretical physicist who developed the theory of relativity. It is one of the two pillars of modern physics. And now, we are going to discuss the 7 types of EM waves that can be found in the electromagnetic spectrum. First, we have radio waves. It is the longest wavelength but lowest frequency. It is produced by making electrons vibrate in an antenna. Radio waves are used to transmit sound and picture information over long distances. They are also used to broadcast radio and television. Next, we have microwaves. They have smaller wavelengths compared to radio waves. They are used in satellite communication, radar, TV transmission, and even in cooking. Next type is we have infrared. Infrared radiation lies beyond the red end of the visible light. It is emitted by all objects. Our bodies radiate infrared, and under the red camera or night vision goggle, our images appear in a variety of colors. Next, we have visible light. Light is the only EM wave that can be perceived by your eyes. Hence, it's obviously the most important for you to observe the things around you. The greatest source of light on Earth comes from the sun. And visible light makes things able to be seen. Therefore, without light, we are not able to see the beauty of God's creation. Next type of EM wave is ultraviolet. Further increase in temperature and energy of a body compared to the shortest wavelength of visible light falls under the category of ultraviolet. This EM wave is produced by very hot objects aside from the visible spectrum they emit, like the sun. UV light can be used to sterilize medical equipment and treat some skin conditions like acne by killing bacteria. UV light can be used to detect forged banknotes and stolen property. Forensic scientists also use UV to detect fingerprints, hair, and bodily fluids that would be invisible to the naked eye. Next is X-rays. X-rays are more energetic region of the electromagnetic spectrum. This EM wave is discovered by Wilhelm Röntgen. X-rays are used to view inside bodies and objects. Lastly, we have gamma rays. Gamma rays have the shortest wavelength but the highest frequency and energy of all EM waves. They are used in medicine for killing cancer cells through the process of radiotherapy. And that's the 7 types of EM waves that can be found in electromagnetic spectrum: the radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. I have here a mnemonic in order for you to easily remember the 7 types of EM waves in an orderly manner. All together, let's read. Royal Marines invade Venus using X-ray guns. Again, Royal Marines invade Venus using X-ray guns. Royal, R stands for radio waves. Marines, M stands for microwaves. Invade, I stands for infrared. Venus, V stands for visible light. Using, U stands for ultraviolet. X-ray stands for X-rays. And G stands for gamma rays. And now, let us discuss the transmission and propagation of electromagnetic energy. 1. We have ground wave propagation, or also known as surface wave propagation. It is a method of radio frequency propagation that uses the area of the Earth and the ionosphere for transmission that can propagate at frequencies below 3 MHz. Second, we have skywave propagation, or also known as ionosphere wave propagation. It refers to radio wave propagation via the ionosphere. This happens when electromagnetic waves travel towards the sky after propagation and reflect the Earth from the ionosphere. Third, we have the surface wave propagation, or also known as tropospheric wave propagation. It can travel directly or after reflecting from the Earth's surface to the tropospheric surface, from the transmitter antenna to the receiver antenna. This is utilized in television and radar communications. Now, let's check your understanding. Instructions. Read each statement and identify if the statement is true or false. 1. Electromagnetic waves travel in a transverse form. 2. The creation of all EM waves begin with an oscillating charged particle, which creates an oscillating electric field and magnetic field. Number 3. Electromagnetic waves do not require any medium for propagation. Number 4. Electromagnetic waves are not deflected by electric or magnetic fields. 5. EM waves travel in free space at the speed of 3 × 10⁻⁹ meter per second. Number 6. EM waves possess the same velocity of propagation in different mediums. Number 7. Michael Faraday discovered electromagnetic induction. Number 8. Heinrich Hertz formulated the concept of photoelectric effect. 9. Gamma rays have the shortest wavelength but the highest frequency and energy of all the EM waves. Number 10. Light is the only EM wave that can perceive by your eyes. Good job, students! And now, know your scores. Here are the correct answers. I hope you enjoyed our lesson. This is Ma'am Maika Villanueva. See you in the next lesson. Thanks for listening.